We have discussed the properties of 4 types of quadrilateral so far: the parallelograms, rectangles, rhombi, and squares. All of these had the properties of the parallelograms and were categorized in the family of parallelograms. The 5th type we're going to discuss today is a kite. The kite does not fall under the umbrella of a parallelogram. The definition of a kite is a quadrilateral with exactly 2 pairs of congruent consecutive sides. So our first property we're going to talk about is the fact that there are 2 congruent consecutive sides. And so let me label the picture. That means that this side and this side is congruent, and this side and this side is congruent. You can obviously, looking at the kite, see that this side and this side aren't congruent, this side and this side are congruent, but these actually look like they are. The second property that it holds is that there are exactly 1 pair of opposite angles that are congruent. So we're going to write exactly 1 pair of opposite angles congruent. So the opposite angles that are congruent is this entire angle here, and this entire angle here is congruent. The third property that a kite holds is that their diagonals form 90 degrees. Form 90 degrees. So at each of these we would draw our 90-degree angles. The fourth property that a kite holds is that 1 diagonal is bisected. Now, if we look at our diagonals here, you can kind of tell which one's bisected. If you look at this long one, we see that this piece is obviously a lot shorter than this piece here. So it has to be this diagonal right here that's being bisected. So this diagonal is congruent to this one. So in the fourth property, we want to put 1 diagonal is bisected. Then, the 5th property that a kite holds is that the 2 side angles are bisected. So 2 side angles are bisected. So if we think about it like a kite that we fly, the sides would be this side and this side. So these 2 are bisected, which means this piece is congruent to this piece, and this piece is congruent to this piece. Now, the last property that it holds is the fact that it forms 2 isosceles triangles. So we're going to put 2 isosceles triangles. So I'm going to highlight so you can see this. Here is the first one. So this would be our first isosceles triangle. And this would be our second isosceles triangle. And you can kind of tell this if you are already looking at the sides. We know that 2 consecutive sides are congruent. So if we look here, we have this side and this side is congruent. So if that's true, that's an isosceles right there. And we also have that this side and this side is congruent. So if we look, we should be able to see the isosceles triangle there as well. What's neat about this is if this is an isosceles triangle, that means the angle across from the side are congruent. So here we would have this angle right here, and I drew a heart to symbolize it, would be congruent to this angle here. And it would be the same for this side. The angle across here would be congruent to the angle across here. So this time I'm going to draw a dot. So this angle here is congruent to this angle here, which makes sense. We said this whole angle is equal. So a heart plus a circle would be the same thing as a heart plus a circle. So you can see how and why this whole angle is congruent to this whole angle. Okay, so that's a lot drawn on one thing. So I wanted to split it up for you so you could see. So we're going to look at just the sides. So if we're looking at just the sides, we know that two pairs of the sides are congruent. So we know that this and this is congruent, and this piece and this piece is congruent. And that's all we really need about the sides. But for the angles, we know opposite angles are congruent, and so we have this angle and this angle is congruent. Our diagonals help us form 90 degrees in the center. So we're going to go ahead and draw our 90 degrees. We also know that they form isosceles triangles, which means that this angle here is congruent to this angle, and we know this angle is congruent to this angle. And we also know that our exactly one pair of opposite angles are congruent. Actually, I left off one of them. So let's go back. In this picture, this diagonal here is going to bisect these angles up here, and so I forgot that, so let's write that in as our seventh top and bottom angles are bisected. So that means that this piece here, or this angle, is congruent to this angle, and this angle here is also congruent to this angle here. So going back to our angles, this piece here is congruent to this piece, and this piece here is congruent to this piece. Now I think for the sides we should include the diagonals here as well. And we were told that one of the diagonals is bisected, and so that means here we have this piece is congruent to this piece. So there's our sides, there's our angles. Now if I'm wanting to solve problems using sides or angles, for sides I would use consecutive sides are congruent, so this equals this or this equals this. And then for angles, we would know that top and bottom angles are congruent, or well, they're bisected. So this piece would equal this piece would equal this piece. We know the side angles are congruent, so this whole angle is equal to this whole angle. We know that the diagonals form 90-degree angles. We also know that here the diagonals bisect side angles. And then also you need to know that triangles add to 180. That's going to be really helpful. And then if they gave you, if you had to use it solving for diagonals, we would know that our side to side diagonal is bisected. And then again, it goes along with the angles that diagonals form 90 degrees. So the kites have a few more properties than all the other ones. These problems will take a little bit more thought. So make sure that you have all these properties written down and are ready to start solving.